You wrote it right there in the system prompt. Never issue a refund over $500. And the agent just refunded $4,200. It did not malfunction. It is a language model. A prompt is a strong suggestion, not a guarantee. This episode is about the difference between asking an agent to follow a rule and making it impossible to break. Welcome back to the CCA exam prep course, episode 4. Hooks, enforcement and session state. Still domain 1, and this is where a lot of people lose points because the exam keeps asking prompt or guarantee. Here is the mental model the whole domain runs on. Anything you put in a prompt is probabilistic. The model usually follows it. Usually is not always. There is a non-zero failure rate. Anything you enforce in code is deterministic. It happens every time, or it is blocked every time, no exceptions. So the exam question underneath every scenario is, does this rule need a guarantee? A friendly tone? A prompt is fine. If it slips once, nobody gets hurt. Verify identity before a financial operation? That needs a guarantee. A 1 in 1,000 slip is a security incident. When deterministic compliance is required, prompt instructions alone are the wrong tool. You move that rule into code. The first enforcement pattern, the prerequisite gate. A gate blocks a downstream tool call until a prerequisite step has actually completed. Take the customer support scenario. The rule is never process a refund until you have verified the customer. So you block process refund programmatically until get container has returned a verified customer ID. Not please verify first in the prompt, blocked in code. If the verified ID is not there, the refund call cannot fire. The agent can still reason, still plan, still call other tools, but that one door stays locked until its prerequisite is met. That is the difference between an instruction and a gate. Gates are one case of a more general mechanism, hooks. A hook is code that sits on the wire between the agent and its tools and runs automatically. The agent SDK gives you two you need to know. First, pre-ToolUse. It fires before a tool call executes and it can block that call. The agent tries to refund $4,200. The pre-ToolUse hook checks the amount, returns a permission decision of deny, and the refund never happens. Then it redirects, hand this to a human. The policy is enforced in code, not hoped for in a prompt. And the deny carries a reason, which goes back to the agent so it understands why and can take the alternative path. This is the exam's favorite distinction. Hooks for deterministic guarantees versus prompts for probabilistic compliance. When the business rule must hold, you reach for the hook. The second hook is PostToolUse. It fires after tool returns and it can transform the result before the model ever sees it. The classic use, normalization. Your agent talks to several MCP tools and they disagree on formats. One returns a Unix timestamp, one returns ISO 8601, one returns a numeric status code. A PostToolUse hook rewrites all of them into one consistent shape using updated tool output to replace what the agent receives. Now the model reasons over clean, uniform data instead of wasting tokens and making mistakes untangling three formats. Block bad calls on the way out with pre-ToolUse. Clean messy results on the way back with PostToolUse. Enforcement also covers what happens when the agent hits its limit and escalates to a human. Here is the trap. The human agent does not have the conversation transcript. They are picking this up cold. So the escalation cannot just say, "Customer is upset, please help." It has to compile a structured handoff summary, the customer ID, the root cause, the refund amount, and the recommended action. Everything the human needs to act in one packet because they did not see anything that came before. A good escalation is a clean briefing, not a shrug. One more design decision, the exam tests how to break a big task into steps. 2 patterns. Prompt chaining is a fixed sequential pipeline. Step 1, then step 2, then step 3, known in advance. Good when the work is predictable. Dynamic decomposition builds the plan as it goes, generating subtasks based on what it discovers at each step. Good for open-ended investigation. The guide's example is a code review, which is exam scenario 5. You do not review a whole code base in one giant pass. Attention gets diluted and the model misses things. Instead, a per file local pass that analyzes each file on its own, then a separate cross-file integration pass that catches what spans files. Predictable multi-aspect work, prompt chaining, open-ended exploration like adding tests to a legacy code base, map the structure first, then a prioritized plan that adapts. Last piece, managing state across sessions. Tasks 1.7. 3 things to know. 1. Resume. You continue a specific private conversation by its session ID resume in the agent SDK or the resume flag in Claude code. 2. Fork. We met this last episode. Fork session branches from a shared baseline into independent explorations, each with its own new session. 3. And this is the tested judgment call. When you resume a session after the underlying files have changed, the agent is holding stale tool results. It thinks the code still looks the way it did before. 2 rules. If you do resume, you must tell the agent what changed since. And often, starting a new session with a clean, structured summary is more reliable than resuming with stale results dragging along. Fresh summary beats stale state. Apply it. Scenario 1, the customer support agent. Company policy: refunds over $500 must never be issued automatically. They go to a human. How do you enforce this? Option A. Add a clear, emphatic instruction to the system prompt: never auto-issue refunds over $500. Option B. A pre-tool-use hook that denies any process refund over $500 and redirects to human escalation. Option C. Ask the agent to double-check the amount before calling process refund. Option D. A PostToolUse hook that flags large refunds after they are issued. Walk it. A is a prompt probabilistic. Most of the time is not good enough for money. Gone. C is also just a prompt instruction dressed up as a check. Same non-zero failure rate. Gone. D acts after the refund already went out. The money is gone, flagging it is too late. Gone. B. A pre-tool use hook that denies the call before it executes and redirects, deterministic before the fact. That is the guarantee the policy demands. Lock in 4 things. Prompts are probabilistic, code is deterministic. When a rule must hold, enforce it in code. Prerequisite gates block a downstream call until its prerequisite has actually completed. Pre-tool-use blocks or redirects calls before they run. Post-tool-use transforms and normalizes results after. Escalate with a structured handoff and prefer a fresh summary over resuming with stale state. Next episode, we leave domain 1 and start domain 2. Tool design and MCP integration 18%, and the place most people's tool schemas quietly cost them points. Subscribe and I'll see you in episode 5.